Welcome to Sri Chaitanya. This is Umasankar, All India IT Coordinator. Welcome to Vector Algebra classes. This is lesson number 9 in Vector Algebra. So far, we have successfully completed 8 lessons in Vector Algebra. Today, through this line, we are concentrating the vector product or cross product between the vectors. Again, my friends, please don't forget to check the description. There I am providing very good important assignments and links of the previous videos also. In lesson number 7 and 8, we have successfully completed dot product and problems based on the dot product and applications of dot product. Today, through this lesson, we are completely concentrating on the definition of the cross product, properties of the cross product, geometrical interpretation of the cross product or vector product, and shortest distance. These two are very, very important for competitive examinations, because several times problems were repeated exclusively on these two areas. Okay. Now coming to vector product of two vectors. Yeah. See, if A bar and B bar are any two vectors and theta is angle between them, then cross product or vector product between two vectors is denoted by A bar into B bar. We can read it as A bar cross B bar, and is defined as A bar cross B bar is equal to mod A bar mod B bar sine theta n cap. What is theta? Angle between A bar and B bar. What is n cap? That is the unit vector perpendicular to both A bar and B bar. So that A bar B bar n cap form a right-handed system. That means, suppose this is vector A bar and this is vector B bar, and this is angle theta. This is the unit vector n cap, which is perpendicular to both A bar and B bar. So they form a right-handed system. So if I have rotated, so apply thumb rule, right-hand thumb rule formula. So the thumb in which direction is there, the resultant vector is also like that. So whenever I am rotating A bar to B bar in anti-clockwise direction, where my thumb projection appears, in that direction only the required unit vector acts. Okay. So this is the way. So where n cap is the unit vector perpendicular to both A bar and B bar, such that A bar, B bar, n cap form a right-handed skew system. My friends, based on this funda only, questions they may give tricky questions. That's why you need to focus on this. Remaining all other things are very simple for you. Okay. And of course, this is the relation between cross product and vector product. And this is called Lagrange's identity. Name point of view, Lagrange's identity. So A bar cross B bar whole square equal to mod A square mod B square minus of A bar dot B bar whole square. In determinant form, you can write like this. A bar dot B bar whole square is nothing but what? A bar cross B bar whole square is nothing but A bar cross B bar dot A bar cross B bar. This is the way. Proof is also very simple. Actually, just by simplification of this one, you will get this answer. By simplification of this itself, you will get the answer. Okay. And moreover, how to easily remember? You take the determinant. So A dot A and A dot B. A dot A, you write A dot B. B dot A, you write B dot B. Simple. So what is a 2 by 2 determinant? Determinant of A, B, C, D is equal to what? AD minus BC. Like this, you can simplify. Okay. So with this, you can find the relation between dot product and cross product. So the formulation of vector product in terms of the scalar dot product is like this. And moreover, C bar dot A bar equal to 0 and C bar dot B bar equal to 0. Therefore, A bar, B bar, C bar, because since this is the vector perpendicular to both A bar and B bar, so this is A bar, B bar, C bar, they form a right-handed system. Moreover, whenever cross product between two vectors is 0, then one vector is parallel to another vector, or they are collinear vectors, provided the vectors are non-zero vectors. But the most important point is A bar cross product is not commutative. That means A bar cross B bar not equal to B bar cross A bar, whereas dot product is commutative. That means A bar dot B bar equal to B bar dot A bar. This is a simple concept, very important. With several counter examples also, you can identify the result very easily. Next thing, MA bar cross b bar is equal to a bar cross m a bar. You can write scalar multiplication like this. So m into a bar cross b bar. And similarly, phi bar, j bar, k bar, they form a right-handed tied system because I, j, k are unit vectors along ox, oy, oz. Then there in a dot product I dot I is 1, whereas in I cross I equal to 0 because mod I sine of angle between I and I, because sine angle between similar vectors is always 0, therefore sine 0 0. That's why I cross I 0, j cross j 0, k cross k 0. In this case only I cross I equal to I cross I, because here it is also not always, not in general a bar cross b bar not equal to b bar cross a bar. If the vectors are equal, then only in the case a bar cross b bar equal to b bar cross a bar. And moreover, the cross product of I cross j, see, the order is important. I cross j is equal to k, j cross k equal to I, k cross I equal to j. Be careful that, don't get confusion. And how to practically solve the problems of how can we find a bar cross b bar. See, this is a bar, suppose a1i plus a2j plus a3k and b bar equal to b1i plus b2j plus b3k. Then a bar cross b bar is equal to determinant ijk. Write the coefficients of ijk of first vector and write coefficients of ijk of second vector, and you expand it. You can get the result by directly by taking the expansion itself. Thereby you can use I cross I equal to 0, j cross j equal to 0, and I cross j equal to k, like that. After simplification, you will get the same expansion of the determinant. If you have expanded this, you will get some terms in terms of ijk. So that means something into I plus something into j plus something into k. That means cross product is again a vector. That is why it is called what? Vector product. So whenever we are applying the cross product between two vectors, the resultant is also a vector. That is why we call it as what? Vector product. Whereas if we are applying the dot between two vectors, the resultant is a scalar. That is why dot product is called what? A scalar product. Okay, this is another important concept. Suppose you consider OA, PC. This is a parallelogram where A bar and B bar are the adjacent sides of the parallelogram, and adjacent sides A bar and B bar are the adjacent sides, and theta is angle between them. Then mod of A bar cross B bar indicates what? The area of the parallelogram whose adjacent sides are A bar and B bar. So the geometrical interpretation of cross product is what? Area of the parallelogram. So geometrically, what does it mean by mod of A bar cross? What is geometrically dot product? Projection of a vector and unit vector product of the first vector and projection of the vector projection of first vector on second vector, like that we discussed in the previous lesson also. So vector product means it is an area. It is what? It is an area. Actually, magnitude of the vector product indicates area, whereas vector product indicates what? Vector area, I can say. Vector area of the parallelogram also I can say. Or simply I can say cross product between two vectors is vector area of the triangle at which A bar and B bar are also the adjacent sides. That is also another geometrical interpretation. Anyhow, cross product is nothing but the indicates what? Area. Okay. Now my friends. Next, unit vector perpendicular to the plane of A bar and B bar. Because already you know, because if it is my A bar and it is my B bar, and if theta is angle between them, and this is the unit vector n cap, which is perpendicular to both A bar and B bar. This is unit vector A bar n cap perpendicular to both the A bar and B bar. So unit vector perpendicular to the plane of A bar and B bar is denoted by n cap, which is equal to A bar cross B bar by mod of A bar cross B bar plus or minus. Why plus or minus? The unit vector may either in this direction or along this direction. Two different unit vectors will occur. That's why we are using plus or minus. So this is the formula. Whenever two vectors are given for you, we need to find unit vector perpendicular to the plane of A bar and B bar. This is the way to solve the problem. Okay, this is the way to find the unit vector. Because you know, and this has been derived from what? From the definition only, because mod A bar cross B bar equal to what? Mod A bar mod B bar sin theta n cap. Sin theta n cap. From that only we have derived this one. Okay. Now, This is what plus or minus r bar into a bar cross b bar by mod of a bar cross b bar. This is unit vector. If you have multiplied this with some magnitude, that indicates what? Any vector perpendicular to the plane of a bar and b bar. Because for the plane of a bar and b bar, for any two vectors, they form a plane. They are always coplanar. There exist several vectors which is perpendicular to this plane. There exists infinitely many number of vectors which is perpendicular to this plane. Of that, there exist only two vectors which are not only perpendicular but having magnitude 1. They are called what? Unit vectors perpendicular to the plane. So any vector which is perpendicular to the plane of a bar and b bar having magnitude r is represented with plus or minus r into a bar cross b bar by mod of a bar cross b bar. Okay, this is also very important concept. And suppose if theta is angle between the vectors, you know that mod a bar cross b bar is equal to formula is what? Mod a bar mod b bar sin theta and cap, where theta is angle between. You take modulus on both sides, it becomes what? Mod a bar mod b bar sin theta, because mod n cap is 1. Therefore, sin theta is equal to what? Mod of a bar cross b bar by mod a bar mod b bar. But my suggestion would be, whenever they are asking you to find angle between two vectors, better you always find a cosine angle only, and that means cos angle only. Don't go for sine angle. But formula point of view, it is good. Okay. Now coming to vector area. Suppose if a bar, b bar, c bar are 3 points or vertices of a triangle are given for me, so like this, then a vector area of this triangle is given by half into a bar cross b bar plus b bar cross c bar plus c bar cross a bar. This is what? Vector area. If I have taken modulus, that gives what? Area of the triangle formed by the vertices capital A bar, capital B bar, capital C bar. So, if this area is 0, simply I can say that the points are collinear. This is another litmus condition at which the 3 points are collinear. The same funda, again, we can apply for solving the problems, and you may apply the same funda even for to test the collinearity of the 3 points in our first lessons also. Okay, try it. And of course, if diagonal vectors are given for me of a quadrilateral, suppose this is a quadrilateral, say this is my quadrilateral A, B, C, D, and this is one diagonal and this is another diagonal. This is diagonal D1 and this is my diagonal D2. Then vector area of this diagonal quadrilateral is given by half into D1 bar cross D2 bar. This is what vector area. Please try to understand. Try to listen the terms very properly. Vector area is half D1 cross D2, whereas area is half mod D1 cross D2. This is what? Vector area of the diagonal. All the proofs are available in our integrated textbook. You just go through them and you will get complete awareness on the proofs. Here I am just giving the formula only, because once if you are master this formula, then solving the problems becomes very easy for you. But try to understand the concept behind them. And here, how to get the area is important. Just with the help of the what is called geometrical applications and simple trigonometry relationship, you can get the results very easily. Okay. Now coming to the shortest distance between. This is one of the most important. Even in last year, even in 2021 mains examination, also several times questions were repeated. My friends, actually, if two lines in space intersect at a point, obviously the shortest distance between them is 0. Clear? Shortest distance means what? Suppose if this is the distance between these two lines. So this is the point where they intersect. That means there is no distance. That means whenever two lines are intersect, shortest distance becomes 0. If two lines are not intersect and they lie on two different planes, they called the skew lines. So here I introduced a new definition, skew lines. So lines which do not intersect and are also not parallel. See, actually, parallel lines never intersect in coordinate geometry. And if two lines are not parallel, definitely they should intersect. But here what I'm saying is two lines which are not parallel, and if they are not intersect, then they are called skew lines. Imagine, then the two lines should lie on two different planes. Okay. So for skew lines, the direction of the shortest distance would be, suppose this is one line and this is another line. So this is on one plane. Imagine a plane like this, and imagine another plane like this. This is one line and this is another line. These two are not parallel. These lines are called what? Shortest distance. So suppose this is a point on this line and this is a point on this line. The minimum distance of these two lines is called what? The shortest distance. So here, how to define? Suppose for skew lines, the direction of the shortest distance would be the perpendicular to both the lines. So shortest distance is what? The shortest distance would be the perpendicular to both the lines. The magnitude of the shortest distance vector would be equal to that projection of AB bar along the direction of the line of shortest distance LM bar is parallel to P bar cross PQ bar. So see, listen, suppose this is the situation. See, this is the line L and M. It is perpendicular to both the lines L1 and L2. These two, L1 and L2, are two skew lines. And LM is the line which is perpendicular to both L1 and L2. Then LM is called the length of the shortest distance, and the line LM is called line of the shortest distance. Okay, my friends. How to find that line of the shortest distance? That is important. So the line which is perpendicular to both the skew lines means what? They are non-intersecting, non-parallel lines. That means they lie on two different planes. So a line, you just imagine, which is perpendicular to both the lines. Suppose this is a line and this is a line. So if a line which is perpendicular to both the lines, then the length of that line indicates what? Length of the shortest distance. And that equation of the line is called equation of the shortest distance. Okay. See, this is the situation. This is the situation. Okay. And here, suppose through this diagram, LM bar, this LM, you say, this is AB. Projection of AB bar on LM. So LM bar is the projection of AB bar on LM. So projection of AB bar on P bar cross Q bar, because this is a skew line and this is another skew line. And suppose this is the suppose this is R bar is equal to P bar plus TS bar, and this is R bar is equal to Q bar plus lambda T bar. So these two are the lines. These two are the two skew lines. This is one line and this is another line, because this is the equation of line passing to the point P bar and parallel to the vector S bar. This is the equation of line passing through the point Q bar and parallel to the line parallel to the vector T bar. So this is what? This is projection of AB bar, because this is suppose say P bar and say this is suppose Q bar. This is vector AB bar. So this vector AB bar, projection of this vector AB bar on ALM bar. Projection of this vector AB. So what is projection? Suppose this is a line given for me and this is a line. So far we have talked about or discussed about projection of a vector on another vector. Suppose this is a line. This is line L1 and this is line L2. Suppose this is a segment AB. How to find projection? You draw a perpendicular from A onto this line, let it be L. You draw a perpendicular BM on this line. This is perpendicular from A onto this line, and this is perpendicular M on this from this point onto this line. Then segment LM is called what? Projection of AB on LM. How to calculate this? You draw a line parallel to this one, let it be theta, and suppose this is AC, you say. So AC is nothing but what? LM is nothing but what from the diagram? AC. AC is what? What is cos theta from the diagram? Suppose cos theta is equal to, from this diagram, this is AL by AC by AB. Okay, so AC is equal to what? AB cos theta. So this is AB cos theta. What is AB cos theta? This is what? Projection. This is what? Projection. The same thing I have mentioned here. The same thing I have mentioned here. But you will get the detailed concept in a three-dimensional geometry very neatly. But before that, suppose if R bar is equal to P bar plus T into C bar, and R bar is equal to Q bar plus some S into B bar. Suppose these two skew lines are given for you. Then projection of do like this. R bar is equal to A bar plus TP bar. R bar is equal to B bar plus TQ bar. Then projection of what is called shortest distance between these two lines is equal to B bar minus A bar dot P bar cross Q bar by mod P bar cross Q bar. This is the formula to find shortest distance between two lines. Okay. And moreover, my friends, the two lines directed by P bar and Q bar will intersect only if, suppose, if two lines means the shortest distance between two lines is 0, then automatically we can say that the lines are intersected to each other. That means this is 0. This is 0 if only the dot product is 0. That means B bar minus A bar lies on the plane containing. Whenever B bar minus A bar lies on the plane containing P bar and Q bar, then a triple product between these three vectors is 0. That is B bar minus A bar, P bar, Q bar equal to 0. You imagine just. So whenever the vectors are coplanar, means the line's shortest distance is 0. That means the vector B bar minus A bar, P bar and Q bar, what? They are what? Coplanar, they lie on the plane. So, okay. Now, suppose R bar is equal to, R1 bar is equal to A1 bar plus KB bar and R2 bar is equal to A2 bar plus KB bar. These two are two parallel lines. How can we say these two are parallel? See, KB bar and KB bar is given because this is the equation of the line passing through point A bar and parallel to B bar, and this is also equation of the line passing through point A2 bar and parallel to B bar. So these two lines are given for me. So there are two lines. These two lines are said to be parallel, and then distance between the two parallel lines is given by D equal to mod of B bar cross A2 bar minus A1 bar by mod B bar. And problems based on this one also recently in JEE Main examination they were asked. So this is about what? The distance between two parallel lines. In coordinate geometry, you know that if A1x plus B1, AX plus BY plus C1 equal to 0, if AX plus BY plus C1 equal to 0 and AX plus BY plus C2 equal to 0, two parallel lines are given for you. If D is the distance between them, what is the distance between these two parallel lines? Mod C1 minus C2 by root of A square plus B square. This is the formula of distance between parallel lines. And same line, if two lines are given for you in vector algebra and the lines are parallel, then the distance between the parallel lines is given like this. But in vector algebra, they never mentioned that the lines are parallel. You need to find, because whenever the vectors are in this kind of structure, automatically understand that, okay, they are parallel. So if they want to find the distance, you just immediately apply this concept, you will get the answer very easily. Okay, my friends, hope you enjoyed this video. If you like this, you please share and subscribe my channel, and please don't forget to press the bell icon, and we will meet with the next lesson soon.